This is Mr. Erlin working with solving missing sides using the law of sines. So this applies when we've got a triangle and we're given certain information, but we recognize that it's not a right triangle. So I can't use SOHCAHTOA. For example, let's say that I'm given that the measure of angle B is equal to 51 degrees, and that the measure of angle C is equal to 28 degrees, and that AC is equal to 6. Step one, let's put in our information. So if B is equal to 51, C is equal to 28, AC, so from A to C is equal to 6. And what I'm looking for is AB. It doesn't say that. AB is equal to question mark. So this one is my X. In order to solve a triangle that does not have a right angle, we can't use SOHCAHTOA. Instead, we use something called the law of sines. And what the law of sines says is that there is a relationship between the angle and the side opposite it. The angle and the side opposite it. But it's not a linear relationship or a one-to-one relationship. Instead, it's related through sine. Turns out that if I take the sine of angle A over the side opposite it, side A, lowercase a, that's going to equal the sine of angle B over the side opposite it, called little b. And that's also going to equal the sine of angle C over the side opposite it. And I can choose that pair, or that pair, or that pair. It doesn't matter. So what I'm going to do is I'm going to look in this picture and see if I have an angle and a side that match up. You see how I've got this 51-degree angle and this 6 length side. That tells me that these two are a matched set. So that's good. I'm going to use B here because I've got B and little b. And I'd see that I've got C. I've got an angle measure here, and I'm looking for the side opposite it. So that's good. I want to use this one as well. I'm not going to use A. I don't have angle A. I don't have the side that would be labeled little a, the side opposite angle A. I'm just going to use this. It's going to be a ratio equals a ratio. This one is the sine of angle B. So I'm going to enter that in. Sine of 51 over the side length, which is 6, equals the sine of C. So sine of 28 over its side length, which is X. All right, this is my geometry. Now I'm going to cross multiply and solve. X times this chunk. So X times sine of 51 equals 6 times sine of 28. I want to solve for X. Right now it's being multiplied by sine of 51. I need to undo that. The way I'll do that is I'll divide by sine of 51. If I do it to one side of the equation, I have to do it to the other side of the equation. These cancel, leaving me just with X equals this mess. 6 times the sine of 28 over the sine of 51. That's my precise answer, but I want a decimal equivalent. So I'm going to punch it into my calculator. Now this is where it gets a little bit interesting. If I've got a calculator that allows me to just show what I'm doing, it's pretty simple. I do 6 times sine of 28. Now, I've noticed in some other videos that I really have to close that parentheses. Watch what happens if I don't. Divide by sine of 51. Notice that that is now hidden inside the angle. And if I did that, I'd get a weird answer. What I really want to do is 6 times sine of 28, and I want to close that parentheses, end the sine operation. I'm taking the sine of that 28 and then moving on to my next step, which is dividing by sine of 51. And it's not a huge difference here, but it would be a big difference in other types of problems. 3.62458. I want to round the nearest hundredth, so I look at this 2 and say, does this 4 round it up? No, it's closer to the bottom. So I'd say X is about 3.62. And that would be the value of side AB in this triangle using the law of sines. We won't be using the law of sines to find missing angles at this point, but this is the way we use law of sines to find missing sides.